So hopefully everyone can hear me. All right, so this is going to be a little bit of a, I know we're not supposed to do sales pitches. This is going to be a sales pitch, not for AWS, but for some work we did integrating Nickel and Libfabric, trying to build more, rather than talk about the work we did, try and talk more about how we want to build a community and how we're thinking about the work. There was a slight screw up in the slides. I sent the wrong version. The first thing that I screwed up is I left out all the co-authors. I really apologize to them for this. So Rashika Kira, who's here in the front row, did most of the work. So anywhere I say something technically stupid, that's my fault, not hers. And she'll yell at me later, I'm sure. As well as Zorik and Leah, two of our developers who couldn't be here. So basically, AWS, quick, just sending context sales pitch. AWS recently announced what we're calling EFA, which is an OS bypass network adapter for HPC and machine learning workloads. It's not quite a full RDMA, verbs RDMA interface like everyone here is used to, but has a lot of the OS bypass constructs, supports a UDQ pair as well as a reliable protocol. Raghu is going to be giving a talk, I believe, tomorrow on some of the details of the integration work we've done. But a quick overview, it's 100 gigabits Ethernet underneath, OS bypass with UD and then a custom reliable datagram protocol. And we've chosen Libfabric as the primary way we expose the capabilities of EFA to our customers. So when customers come to us and say, hey, how do I run MPI on top of this, or GasNet, or any of the custom middleware, the answer is through the Libfabric interface. And we're supporting a variety of what we call instance types, so hardware, including one with a whole bunch of GPUs, not worth going into. But the next question that obviously comes up is, okay, you've built this EFA thing, you've built this GPU thing, how are you going to glue them together? And historically, most of our customers have been using a software package that eventually ends up using Nickel for one of a bunch of software packages that eventually ends up using NVIDIA's Nickel Collectives package. Whether it be Caffe, MxNet, which is kind of where most of our customers are, just because it's where we're pushing a bunch of support. TensorFlow, PyTorch, any of these, eventually under the covers can use NVIDIA's collective library. And for those who don't have any idea what I'm talking about, NVIDIA put together a communication library that's mainly focused on collectives necessary for big machine learning training applications, called it Nickel, and everyone started adopting it, at least in our customer base. I'm sure particularly with the Intel people in the room, they see a different story there. But and Nickel 2, which came out about 6 months ago, is largely focused on distributed node training. So it supports both multi-GPU inside an instance or a node, and then multiple GPUs across multiple nodes. And so we had to glue the two together and built a Libfabric plugin for Nickel 2. Now, as a primer, quick, so that some of the details of what we built make sense, Nickel has this concept of rings. And a ring is essentially a communication path through their virtual topology. So you might have, in this first case, a single ring, which is there's a single path through their network. Or you can have, in some of their more complicated architectures, what they'd call a 4-ring setup, where there's 4 paths through the network that obviously overlap at some points so that data can flow in multiple directions. In the multi-node construct, their preferred way of running is what they'd call a single ring mode, where you have a kind of a topology through the network through the one node network that is one path through, and then a whole bunch of these multi-nodes glommed together. This causes a couple of challenges if you're using a TCP Ethernet-based network like we are, in that if you look, you essentially have, in this case it's IB, but if we swapped that into ENA, you'd have one TCP socket with data coming in and one TCP socket with data going out. And if you have, say, a 100 gig Ethernet network, you end up with trying to drive essentially 100 gig through one TCP socket, which is unlikely to be successful. And so customers have started looking at how do we run with multiple rings, and this influences our design a little bit towards the end in terms of that leads to more and more connections. It's also possible that the rings aren't quite as well set up as this, and you can end up with kind of a connection explosion if you're not careful. So it turns out Nickel 2 has a plug-in interface for network adapters. It's a fairly simple interface. It's 10 functions that you have to provide. The standard initialization and cleanup functions are there. You know, tell me how many NICs there are. Tell me which NICs are close to which GPUs. Of course, start up and then shut down. And then some functions for determining capabilities, like can the network card directly send out of GPU memory? For Mellanox verbs, the answer is obviously yes. For TCP, the answer is obviously no. And everyone else is kind of somewhere in the middle. Its connection establishment is a standard listen, connect, accept interface. So something more akin to setting up an RC-Q pair or TCP compared to, say, MPI style of boom, all the processes are connected. So at the low layer, you see an explicit accept connect, listen, accept, connect profile. Memory registration is explicit. So Nickel, unlike, say, MPI at the top level, encourages buffer usage in a way that sanely maps to memory registration. And then the lower level fairly explicitly calls register and deregister APIs based on buffer lifespans. And then for those who are familiar with MPI, basically they provide iSend, iReceive, and test functionality for sending a message and completing a message. So everything's non-blocking polling based. Each ring or each connection is an ordered message channel. The messages are generally large, and like I said, there can be multiple channels between any two process. And so this influenced our design a little bit. The first call out is because Nickel believes, the performance of Nickel is dependent on picking NICs close to GPUs. We need FI NIC support to pull out the PCI address of the endpoint we're talking to and wire everything up. You know, FI NIC was added in 1.7, if I have that right. Yeah, in Libfabric 1.7, it's a requirement for us. Otherwise, we can't figure out how how to enumerate it through the host. We use RDM endpoints. We need simple send after send ordering, and somewhat unusually, we decided to go with using the tagged message interface instead of an untagged send receive. And this is somewhat a quirk of our particular hardware, but Nickel is fairly unbounded in how many of these connections it's going to set up. Generally, it defaults to only a couple per process, but there's nothing that guarantees that, and we didn't want to cause a explosion of endpoints we were creating, and also did not want to rely on scalable endpoints just yet for that case where you have many, many rings and therefore many connections between any two processes. Some things that Nickel An awful lot of the people who worked on the nickel communication library at NVIDIA previously worked on MPI, and that shows in a couple of places. Some good, some unfortunate. Like MPI, nickel really has no concept of back pressure. It just keeps sending messages. This is, I think, great if you're an upper layer protocol developer. A little problematic if you're trying to layer on top of something like Libfabric, or even verbs, which eventually is going to return an E again. And so my note, some things never change. But essentially, we did have to write a little bit of logic to queue messages for when the network, the lower level of Libfabric wasn't able to keep the queues full. And I bring that up because our plugin is about 1,500 lines of code total. That's all there is to it. And about half of that is actually dealing with back pressure. And another quarter of that is initialization. And so really you end up pretty small chunk of code to glue these two together, which is, I think, a fairly good testament that the Libfabric community got an interface right that's really good for gluing together a bunch of upper layer protocols. So long and short, it's Apache 2.0 licensed. It's available on GitHub at the URL there, or if you search Libfabric nickel, it'll be on Google, it'll be the first hit. In terms of future work, we do not currently have GPUDirect support in our hardware, so we didn't implement GPUDirect support in the plugin. Obviously, we'll have to do that. We have some thoughts on what we need out of the Libfabric interface. They're pretty close to what Sean has in mind for the GPU support in Libfabric. And obviously, that's totally ignoring all the kernel driver parts, just talking about the Libfabric interface. Performance tuning, I'm sure there's some shortcomings. I'm sure there's some places that we could do better in terms of performance. We're still, we haven't actually released EFA yet. We've announced it, but not released, which means we're still rapidly optimizing the entire stack from the firmware all the way into the Libfabric plugin for nickel. And there's a lot of moving pieces, and so when Rishika says, hey, this is really slow, sometimes it's something that the nickel plugin is doing, sometimes it's things that our Libfabric provider is doing, and sometimes it's things the hardware is doing. So there's a lot of moving pieces. I'm sure there's places we can optimize here in terms of performance. On our, but even today, I don't have any results because, like I said, we haven't shipped EFA yet, and therefore I'm not allowed to put results in a slide. That's a little unfortunate. We were hoping to have shipped by now. But we're seeing fairly significant advantages over our TCP-based infrastructure, but that really isn't saying a whole lot because it's comparing OS bypass to TCP. And then bug fixes. We're just starting to use this for real, so I'm sure there's bugs, I'm sure there's issues we'll run across, but kind of, this is really a call for participation. So we developed this, made it open source, we're going to continue investing in it, but we have only a couple of providers that we can test with. We have only a couple of people who bring one viewpoint into how this should work. So we need provider testing, we need ideas on where we should go next, we need basically a community. So there's a whole lot of people in here who have Libfabric providers. Many of you deal with NVIDIA GPUs, and what we'd love to do is talk to you guys about what's next and where we should go. Not quite the US Army, but that's the version that doesn't have a copyright on it. So thank you, that's really it. Wanted to walk through what we were doing, let everyone know we had built this, that it's an open source thing, that we're really looking for community participation. I know Amazon sometimes gets a bad rap for its open source contributions. This one, we really mean it. It's up on GitHub. We're taking pull requests. File issues, we'll fix the bugs. Yeah, we'd love to hear more. Yeah?
Do you expect it to work with any of the other Libfabric providers? Like even in theory?
So we've tested with, obviously, sockets, TCP, the ones that we can test. Thus far, as long as you provide what I mentioned earlier, tag messaging over RDM, we expect it to work, yeah. Well, so we don't have the ability to test it, hence the call for help. We don't have any OPA hardware that we can use for testing. So like I said, there was a bit of plea for let's test this. We also, like I said, we've tested with the utility providers. And so like it should work, but again, we don't have hardware over Mellanox NICs using the verbs provider and then the RxM provider and then the plugin. So again, we're a little hardware poor outside of EFA and TCP. So
theoretically, it should work over RxM.
correct.
So RxM
Right. Yeah, so for those who didn't hear Woody, it was basically, we've tested with some of the utility providers, the ones we can, and with RxM, you'd have the tag messaging over verbs. My understanding is that path is pretty well tested, and so there's no reason it shouldn't work, and if it doesn't, that's a bug, and we'd love to hear it. Yeah?
Another general question about Nickel itself and its community. So
Yeah.
Nickel is really a specific thing to NVIDIA, right?
Correct.
Is there any other people like looking at, is there any ability for that community to enable, like say there's an AMD GPU or another GPU in the market, make that more broader than just an NVIDIA thing?
So I'll start by saying I'm a networking guy, and that's a machine learning or a question that probably I shouldn't answer. But I'll take on what I do know is today NVIDIA has written it in CUDA and targeted it towards NVIDIA GPUs. So yeah, I mean that is part of the problem in building the community, and we probably need to build similar packages and write similar Libfabric plugins for GPUs other than NVIDIA.
Yeah, I'm kind of thinking that if you wanted to have something that was, vendor agnostic, this is a vendor specific thing.
Correct. Correct. I think it would be, personally, I think it would be awesome to have a GPU agnostic solution here. In the short term, I have to go where my customers are telling me I have to go.
But theoretically, one could start a community and build that even if you use Nickel's.
Correct. And really the big message, one of the big takeaways here that I wanted to put out is, this was not a lot of code we had to write, and we didn't find any huge, okay, Libfabric and Nickel, just the semantic mismatch kind of thing didn't happen. And I think that speaks to the work the Libfabric community's done to support a bunch of different upper layer protocols. Any other questions? Yeah, Jason.
You talked about the GPUDirect. What do you think you need for that?
So I think the biggest thing we need to sort out, so ignoring all the kernel stuff, yeah, we'll talk offline on that one, but from the Libfabric side, I think yeah, no, but I meant let's take it from a user programming interface side. I think the big question is, in my mind, a great interface from a user perspective is I register the buffer. When I register, I say it's GPU memory. And then when I call OFI send or tsend in this case, I don't have to do anything else other than pass a memory registration that flagged it as GPU memory, right? Kind of not making us have an entirely duplicative interface, hiding all of the hard part under the covers, right? Because particularly using tsend or send-receive interface, right? There's a rendezvous protocol. There's so that you can issue the put or get, so that you can land it in the right place in GPU memory. And if we can hide all of that from the customer, so that from the upper level protocol developer, so that what the Nickel plugin still sees is register memory tsend. I think that's really where we've stayed with the kind of Libfabric. Let's take all the complexity out of the upper layer protocol developers area. Does that make sense?
I'd be surprised if there was any other choice.
I think you can quickly get into, well, let's make the customer, let's make the upper layer protocol author, use send receive, and then, like the Libfabric plugin, do the send receive rendezvous protocol, and then issue the RMA op. Like that is one way we could do it. I think that would be a bad way to do it. Correct. You'd still need, I'd really like us to hide the complexity of that rendezvous protocol under the covers. In Libfabric is what I'm saying. Right. Right. No, at the end of the day, that part is definite, right? It's a special MR. So any other questions, comments? Telling us we're insane, that's totally fine. All right, thanks everyone.